Today let us learn the concept of beats. Okay, so what is a beat? See, beat is due to interference. So what is interference? Interference of two waves. Yes. So when two waves, see, if we take waves, these waves will have frequency. So we are taking two waves. These two frequencies must be almost approximately same. Okay. Approximately same means it is not. They are not equal, but for example, let us take 105. Then this can be like 103 or 107 or 110, almost close to. Okay, almost close, approximately same. Okay, so if you take any wave, let us take one wave. We are having frequency of 1. This is one wave. Let us take another wave of 2. So the frequency of this wave is like this. Okay, they are not same. So what happens when they both get superimposed? Interference means superimposition. So when these two waves superimpose, then let us take the first wave. This is the first wave. Let us take second wave. They both got superimposed. So like this, if you see, observe here. Here they are same. But when it comes to here, see here. Can you see? So one will be like this, another will be like this. So when I join both, then the wave comes like this. After mixing both the waves appear like this. Understood? So somewhere here you can see that construction and destruction happened. Here how many like that it happened? That is called beat. Understood? So what is the difference between them? That is known as beat. So the difference will create, yes. So beat frequency is difference between the frequency. It can be F1 minus F2 or it can be F2 minus F1. That is known as beat frequency. Okay. So what are the conditions for beat? First point, same frequency. Second point, same direction. Both should be in same direction. Okay, traveling in same medium. Then we can able to observe beat. Okay, now. So let us take one wave S1 as A cos omega 1t. Let us take another wave S2, A cos omega 2t. Okay. Here why omega 1, omega 2? Amplitude is same, but omega 1, omega 2 is different. Omega is nothing but 2 pi f. Omega 1 means 2 pi f1. Omega 2 means 2 pi f2. Here we can tell that frequencies are different. Therefore omega 1 and omega 2. Okay. Then if these two get superimposed, then we get a resultant wave S. S is the resultant wave of superimposition of S1 and S2. Okay. Then resultant is nothing but superimposition of S1 and S2. Superimposition means they are getting added. Then what will happen? A cos omega 1t plus a cos omega 2t. If I take a common, then it is cos 1 omega t plus cos omega 2t. Okay, if you see here, this is like cos c plus cos d formula. Cos c plus cos d is 2 cos c minus d by 2 cos c plus d by 2. Then what will happen? This formula, this will become a cos omega 1 minus omega 2 by 2 into t cos omega 1 plus omega 2 by 2 into t. Correct? Okay. Here, wherever the frequency got added, okay, we will be getting loud sound. Where frequency has been subtracted, we will get feeble sound. Yes. So we call this one loud. Sorry, this is loud. L-O-U-D. Okay, loud sound. So this loud sound we call it as waxing. This feeble is known as waning. Yes. So waxing and waning with the frequencies equal to the difference of the individual frequency. What is that? Waxing and waning. Yes, waxing and waning with the frequencies equal to difference of individual frequencies is known as beat. You see, this superimposition can happen for both. One for beat, another one even for stationary waves also we can see that waves getting superimposed. Then what's the difference between beats and stationary waves? Okay, in stationary waves what will happen? Same frequency should be there, not similar. Here it can be similar frequency, here it should be same frequency. First, second, here both should be in same direction. Waves should travel in same direction. But in this case, waves should travel in opposite direction. Understood? So that is the difference. Clear? Yes, here slightly different frequency, but here exactly same. So now what is beat frequency? Beat frequency is nothing but difference in the frequencies. F1 difference F2. It can be F1 minus F2 or F2 minus F1. Which is bigger, from that you have to subtract the smaller one. Okay. So now frequency is inverse to the time period. So I can write time period for the beat as 1 by delta F, 1 by FB, right? Beat frequency, which is nothing but F1 difference F2. Now you know in case of strings, stationary waves, what is the frequency formula? F is equal to 1 by 2L root over T by mu. Remember? We also know that F is equal to V by lambda. Okay. So we can use these formulas wherever frequency is there. You can use this F1 difference F2 in this case, if it is a concept of beats. Okay, now. So when it comes to numericals, questions, how they will ask the questions. Okay. So questions will be based on tuning fork. Yeah, when it comes to the concept of beat, questions will be on tuning fork. So how they are going to ask is, if you have tuning fork, this tuning fork, when you put wax Okay, if you don't put wax and you just strike with hammer, it will produce frequency f. Let us consider f of frequency is produced. Now you apply wax on this prongs and now hit with a hammer. What happens to its frequency? When you keep wax on the means increases or decreases frequency? Decreases. Yes or no? Because as mass increased, frequency decreases. So this one we call it as tuning fork loaded with wax. When loaded with wax, it means that frequency will decrease. Okay. Now you have a tuning fork. Now what you did? You used what is that, like for iron, for scrap, to remove that iron rust. What do we use? Right, scrubber. Yes, when you use that scrubber and if you rub this tuning fork prongs, what happens to their thickness? Decrease. Then what happens to its frequency? Increases. Because of thinness, as mass increases, frequency decreases. Here mass decreases, frequency increases. Yes, we call this one whatever the process we use here to make this prongs thinner, we call it as filing, F-I-L-I-N-G, filing, or sharpening. So when we do sharpening, frequency of the tuning fork will increase. Okay now. So here we use a sandpaper to rub this, right? So in this way questions will be asked. Okay, shall we do one numerical? Okay, let us do one numerical on this. First question: if two tuning forks A and B are sounded together, A and B are sounded together, they produce 4 beats. They produce 4 beats per second. Okay. If A is slightly loaded with wax, they produce 2 beats. Okay. If the frequency of A is 256 Hz, what is the frequency of B? This is the question. Understood? So we have two tuning forks. Let us consider here tuning fork A, tuning fork B. Okay. Let us take cases here. Case 1, case 2. What is case 1 is first case, when two tuning forks are sounded together. Second case, when loaded with wax and then they are sounded. So in the first case, let us take that the tuning fork frequency is 256. Frequency of A is 256. Okay. Now see how many beats are produced in the first case? 4 beats. So here let us write number of beats. Okay, number of beats, nothing but EFB. Okay, number of beats is nothing but beat frequency. Here 4. Okay, So now for 4 means this should be either 256 plus 4 or 256 minus 4, right? Then only the difference will be 4. If it is 256 plus 4, it is 260 or 252. Okay, now what happened here? For A it is loaded with wax. What happened for the A? It is loaded with the wax. Means what happens to the frequency of A? Decreases. Okay. Now it decreased, and then both how many frequencies they produced? 2. So what is the difference here? Here they gave you number of beats produced after the wax. 2. Understood? So here 4 and 2 difference is 2, means 2 will be decreased by A, right? Because B is not waxed. We waxed only for A, means how much frequency is there? The frequency will not change for B because we didn't do anything for B. This difference is created only by A. So this will be 256 minus 2. So the frequency of this one will become 254. Now what should be the difference here? Both between them? 2. Means it should be either 250 plus 2 or 254 minus 2. Correct? Then only it will be difference will be 2. In this case. So if you take here 256, here if you take it is 252. Correct? Now see, observe in above and below which is having common. Understood? It means the frequency of B is 252. So what is the frequency of B? 252. Clear? This is the way how we need to solve. Shall we do one more? You could able to understand? So 2 tuning forks, A and B, vibrating simultaneously. Two tuning forks A and B vibrating simultaneously produces 5 beats. Produces 5 beats per second. This is very, very important. Beat should be always per second only. Okay. So if the frequency of B is 512 Hertz, okay, if A is filed, then the number of beats, increases to 2. Number of beats increases by 2. Find frequency of A. Understood? So let us take A, tuning fork A, tuning fork B, beat frequency, number of beats. So in the first case, case 1, case 2. Case 1 is normal. 5 beats are produced. Okay. Frequency of B is 512. So frequency of B will not change. So if difference is 5, means this should be either 512 plus 5 or 512 minus 5. If it is 512 plus 5, then it is 517. In this case, 507. Yes or no? Now, what happened to the beat frequency here? Increased by 2. Means 5 will become 7. Increases by 2. Means 5 plus 2. Okay, now what is the difference here? Difference is 2. Now, what we did here? A is filed. A is filed means for the A, it will be increasing by 2. Means it will be either 517 plus 2 or it will be 507 plus 2. Yes or no? If it is 517 plus 2, it is 519. Here in this case, it is 509. Now difference between these two must be 7. Yes or no? 512 minus 7 is how much? 512. Here what we should do? 519 minus 512 or 512 minus 509. This is 7. In this case, it is 4. 3. Sorry. In this case, it is 3. So now we got for 519. So what is the frequency for A? Frequency for A is when we got 519, when we have 517. This is after filing. But before filing is the frequency of A, which is this value. Understood? Therefore, frequency of A is 517. Understood how to find the answer for this? Clear? Okay. Shall we go with next numerical? One more we will do. Okay. So this is little important. See here, 64 tuning forks. 64 tuning forks are arranged such that each fork produces 4 beats. 4 beats. Okay. With the next one. If the frequency of last tuning fork, okay, is octave of the first. So this name is very important. Last fork is octave of the first. Okay. Find the frequency of 16th fork. So here there are tuning forks like this. They are arranged like that. 64 tuning forks are there. Now when this one touch with this, 4 beats will be produced. When this one touch with this, 4 beats. Like that, beat frequency will be common. Understood? Means 60. See here, last one is nothing but 64th one. Last fork, 64th fork. Octave means it is 2 times, multiple 2 times the first tuning fork. Okay. Yes. This is the meaning of octave to the first. Okay. Now we want 16th tuning fork frequency. Remember nth frequency formula. Fn is equal to F1 plus N minus 1 into F1 plus N minus 1 into beat frequency. Okay, what is beat frequency? F1 difference, F2 or difference. Here in this question, beat frequency is 4. Difference between these two frequencies is 4. Okay, so here we want 16th. We want 16th tuning fork. So 16th tuning fork is nothing but F1 plus 16 minus 1 into beat frequency 4. So to get the value of this, we should know F1 value. Yes or no? 5 4s are 20, 60. We should know F1 now. To find F1, in place of n, put 16. F16 is equal to F1 plus, put here 64. In place of n, put here 64. Yes, because 16 we need to find. 64 is equal to, F64 is equal to F1 plus 64 minus 1 into 4. So in place of F64, what I can write? In place of F64, I can write this one. 2 times F1 is equal to F1 plus 63 into 4. I will send F1 this side. 2F1 minus F1 is equal to 4 3s are 12. 24 plus 1, 25, 252. So F1 is equal to 252. Now I will substitute this. Now I am going to substitute this 252, okay, in this one. Then 16th frequency I will get it as 252 plus 60, that is equal to 312 Hz. Understood? This is the way how we need to solve this question. Okay, so try to solve this type of questions. You will be getting confidence. Okay, next topic is Doppler effect. So what is Doppler effect is? See, we already know about this experience of Doppler effect in our life. See, this is a platform, railway station. We are standing somewhere here on the platform. Okay, this is a railway track. So we have a train. We have a train here. Okay. So this is very far from us. It will horn here. We will be able to hear some sound. Now the same train, when it comes to near to us, the same horn which is produced in the train at this A point and this B point and at this C point is same, correct? The horn will not change the frequency. It will produce same sound, same horn. But what happens when it is far? We hear very less. When it is near, we hear more. When it is going away, again it decreases. So do we feel that there is a difference in the sound from one point to another point? Yes. That difference is being absorbed by Doppler, and that effect is known as Doppler effect. So the change in the frequency produces the change in the ability of hearing the sound. So sometimes you hear ambulance siren. Sometimes you feel that it is coming close, it is going far. Yes. So this kind of effect, it is an effect which we feel. Actually, the sound produced by the ambulance is same when it is with us or when it is going away from us. But we feel that effect, that the sound is decreasing, that the sound is increasing. Correct? This effect is known as Doppler effect. Okay, so whatever we hear apart from original frequency is frequency produced by the source. object source. We call it as source. Here train is our source, ambulance is our source. So what is this doing is it is producing some frequency of the source. Let us take that as frequency of source. Now we are observing that. So we are called observer. So if you see observer here, observer will be hearing the different sound. So that sound which is not exactly equal to this source. Therefore we call it as apparent frequency of the sound. Okay, apparent frequency. Now why this is happening? Why this is happening? When you stand here at rest, there is a ambulance which is next to you. It is also at rest and it is producing siren. You don't feel that there is a difference in the sound. But when you are going away, or when the ambulance is going away, due to motion of this, you feel there is a decreasing or increasing of the sound. So we call it as a relative motion. Due to relative motion, we hear the apparent frequency of the sound than the original frequency of the sound. So what is the important concept here? Relative motion. Relative motion. So we can remember the formula. Okay, what is that? Is apparent frequency what we hear, that is equal to original frequency produced by the source, frequency of the source, okay, into velocity of the sound plus or minus velocity of the observer by velocity of the sound plus or minus velocity of the source. Understood? This is the formula. Now see here. This is observer. This is source. Observer is going in this direction with velocity v0. Source is moving in this direction with vs. Let us take here observer, source. Observer is going with velocity v0, velocity, speed. Source is moving with vs. But listen carefully here. Whatever the source produces sound always will reach from source to the observer. Then this is the velocity of the sound. Here also sound will be produced from source and it will reach to the observer. So what is the direction of the velocity of the sound? Direction of velocity of the sound is always from source to observer. Wherever it is, we are hearing from the source. So it should come in the direction of the observer. Yes. Now if both are in same direction, I told you relative velocity concept. Yes. If both are in same direction. Okay. Let us take here. One is moving with observer A, observer B. Both are moving in same direction. If both are in same direction, then relative velocity will be VA minus VB. Difference between the velocities. Okay, now if both are moving in opposite direction, okay, then relative velocity will be VA plus VB. Now what happens to formula in this case? This is case 1. So in this case, what will happen to our formula? See here, F apparent is equal to Fs into, now see, relation between observer and velocity of sound. Velocity of sound is coming in this direction, observer is going in this direction. Both are opposite or same direction? Velocity of observer is in this direction, velocity of sound is in this direction. Opposite. Opposite means we need to add. Then we should take formula V plus V0. When to take plus, when to take minus. Clear? Now come to this. Observer and source. Velocity of this and the source. V and Vs. Relation between V and Vs. V is in this direction, Vs is in this direction. Correct? Then the formula is they are in opposite direction. Yes or no? They are not in same direction. So in opposite direction, what I have to do? V plus Vs. Understood now? Now let us take in this case. For this case, what will be our formula? See here, F apparent is equal to Fs. This is common because from this formula we have to write. Now what we have to take, whether plus or minus, let us check here. Relation between V and V naught. V is in this direction, correct? V naught is in this direction. Both are in opposite direction. So we need to take V plus V is V plus V naught. V plus V naught, correct? By. Now see, these both are in same direction, V and Vs. So we will take V minus Vs in this case. Understood how to take the formula? In some textbook, instead of Fs, it will be F naught. F naught is nothing but source, frequency of the source produced by the frequency of the sound produced by the source.